Welcome everybody. In this video we're going to discuss DevOps Metrics. DevOps Metrics are data points that directly reveal the performance of a DevOps software development pipeline and help quickly identify and remove any bottlenecks in the process. These metrics can be used to track both technical capabilities and team processes. So first we have the agility performance indicators. Understanding the frequency of how often new code is deployed into production is critical to understanding DevOps success. Many practitioners use the term delivery to mean code changes that are released into a pre-production staging environment, and reserve deployment to refer to code changes that are released into production. High-performing teams can deploy changes on demand, and often do so many times a day. Lower performing teams are often limited to deploying weekly or monthly. The ability to deploy on demand requires an automated deployment pipeline that incorporates the automated testing and feedback mechanisms. Next, we have the change lead time, which is one of the critical DevOps metrics to track. Lead time for changes is the length of a time between when a code change is committed to the trunk branch and when it is in a deployable state. For example, when code passes all necessary pre-release tests. High-performing teams typically measure lead times in hours, versus medium and low-performing teams who measure lead times in days, weeks, or even months. Test automation, trunk-based development, and working in small batches are key elements to improve lead time. These practices enable developers to receive fast feedback on the quality of the code they commit so that they can identify and remediate any defects. Long lead times are almost guaranteed if developers work on large changes that exist on separate branches and rely on manual testing for quality control. Then we have the reliability performance indicators. The change failure rate is the percentage of code changes that require hot fixes or other remediation after production. We need to clarify that this does not measure failures we caught up by testing and fixed before code is deployed. High-performing teams have change failure rates in the 0-15% range. The same practices that enable shorter lead times, test automation, trunk-based development, and working in small batches, correlate with a reduction in change failure rates. All these practices make defects much easier to identify and remediate. Tracking and reporting on change failure rates isn't only important for identifying and fixing bugs, but to ensure that new code releases meet security requirements. The last metric that I want to highlight is mean time to recovery, or MTTR, which measures how long it takes to recover from a partial service interruption or total failure. This is an important metric to track, regardless of whether the interruption is the result of a recent deployment or an isolated system failure. High-performing teams recover from system failures quickly, usually in less than an hour, whereas lower-performing teams may take up to a week to recover from a failure. The ability to recover quickly from a failure depends on the ability to quickly identify when a failure occurs and deploy a fix or roll back any changes that led to the failure. This is usually done by continuously monitoring system health and alerting operations staff in the event of a failure. The operations staff must have the necessary processes, tools, and permissions to resolve incidents. So, continuous improvement is a core tenet of teams practicing DevOps. The ability to measure and track performance across deployment frequency, lead time for changes, change failure rate, and even MTTR allows teams to accelerate velocity and increase quality. I hope you enjoyed this video, and thanks for watching.